In this video, we'll introduce you to React Router, a standard library that the React community uses and prefers for implementing routing in a React application. We'll first understand dynamic routing, a key feature of React Router. Then we'll work through a project where we'll begin by installing the library, followed by using the browser router, link, switch, and route components that help us implement routing easily and declaratively. So let's jump into it. Now that you understand what client-side routing is and how it helps us improve user experience in a single-page application, let's shift our focus on a standard and preferred routing solution that the React community loves. React Router is a wonderfully easy to understand routing library for React apps. Built by Michael Jackson and Ryan Florence, the library offers a stupendous developer and user experience. A great developer experience is key, in my opinion, as it ensures your apps feature legible, error-free, and maintainable code that comes naturally as a part of the development process. One of the great features of React Router is dynamic routing. To understand dynamic routing, we have to understand static routing first. In most web frameworks, such as Ember, Angular, and even Node.js frameworks like Express, routing as a process is based on a configuration. You declare your routes and the templates or components that they should render. This is easy to understand in general, but is still a static configuration sitting in a file that cannot be changed during render time if you have to. React Router takes a different approach to routing by doing away with static configuration and adopting a more familiar approach: components. Routing in React Router happens mainly due to the route component, which keeps an eye on the URLs in the browser's session history stack and renders a suitable component. This statement here will render a component called products if the URL has /products in the path. This is dynamic routing. You're using an API you're familiar with in React, and this offers a great developer experience. To understand how all this falls into place practically, let's say you have an app which needs to load 3 separate components based on unique URLs. The navigation links here can be defined using a special link component that does the job of generating an anchor tag that is all wired up to push unique URLs into the browser's session history stack. In the area on the page where you need to render components based on the URL, you define a switch component within which we create a series of route components, each set to load a specific component. When the navigation links are clicked on, the unique URL is pushed into the stack, to which our route components respond by loading the appropriate component. This is how React Router works in a nutshell. Of course, there's a lot more to it. So let's work through an example application first. Our app aims to be a recipe organizer. The UI has been built using a framework called Ant Design, which simply offers a ready-to-use set of UI components and layout helpers to help you put together a great UI fast. You don't need to worry about this framework or how it works to understand routing in this project. What we have here are navigation buttons at the top, which should load up unique components in the content area on the page. Additionally, in the recipes section, we will offer a second set of navigation buttons, which should cause the lower half of the page to display recipes from a database. And when one of these are clicked, we want to load yet another component to display the recipes. Besides this, the Add Recipes section should only work when the user is logged in, and that is something that React Router easily allows you to achieve. We'll cover all these aspects over a course of 3 videos. So let's begin by downloading the project archive for this video, where we'll set up React Router and our basic routes. As you can see here, our application has a bunch of navigation buttons at the top here, including a login button. You'll notice we have components from the Ant Design framework being imported in here. This framework offers ready-to-use components for quickly scaffolding out a complete website and has been used here simply to save time. For instance, the call or column component lets us render columnized containers using a grid layout that is popular with designers. You can also see the menu component here, which has been used to render the navigation menu that you see on the top. Down here is where we are rendering the main contents of the page. So for instance, the home component has been hard-coded in. If instead I bring up a component called recipes, which we've built to fetch and render recipe cards from a database, you'll see this layout with another navigation menu that features categories of recipes and cards for breakfast recipes. The about component, for instance, which should be rendered when the slash about route is invoked, looks like this. We just have some lorem ipsum here. Likewise, the add recipe component brings up this UI, a form that actually doesn't work and is just a dummy here, but in the real world you'd have something like this in place that is only accessible when the user is logged in. Finally, the login component brings up the login page, which we will use to log in the user to the app. So the first thing I'll do now is bring up another terminal because I have the development server up on the default one. We'll need to use npm to download and install React Router first. I'll thus run npm I React Router DOM and I'll specifically download version 5.1.2 to lock in this version for this project. The DOM at the end of the package name means that this version of React Router is designed to be used in the web browser. You also have an edition designed specifically for React Native when you're building mobile apps. Once downloaded, the first thing we'll need to do is to encapsulate the entire application in an instance of browser router, which I'll import in like so. We are just renaming the instance to router for simplicity, though this step is not needed, and you can directly use browser router as well. The router here is just a component that uses the history API to monitor and keep your UI in sync with changes to the URL in the address bar. So we'll just encapsulate the entire contents of our app within an instance of the router component like so. This is all you need to equip your application to work with React Router. We can now use specific components to implement hyperlinks and define routes. Let's create hyperlinks out of our menu items so that clicking them pushes a new URL in the session history stack, which our router can then observe and react to changes. Instead of using standard anchor tags, however, we'll use the link component from the React Router library. I'll begin by enclosing the icon and the text for the home menu item within a link component instance like so. But the link component doesn't know where to navigate to. So we'll set a to prop here with the root route or a / like so. Likewise, we'll encapsulate the about icon and text within a link component and it should push the / about URL into the stack. We'll repeat this process for all menu items. If you now click on these buttons, you can see the URL change in the browser's address bar, and the page doesn't navigate away as well. This is perfect. The next thing we need to do is to react to these changes in the URL and render the appropriate component in the content box area here. For this purpose, I'll first import the switch and route components from React Router. We'll first create a pair of switch component tags like so, within which we'll create a route component instance that has the path set to the root route or a simple /. In simple words, when the root route is set in the address bar, we want to render the home component. We'll also set a property called exact, which will ensure that the home component will only render when just the / or the root route is invoked. The exact keyword prevents the root route component from getting rendered when other routes emanating from the root onwards, such as /about or /recipes, are invoked. Since the / appears in all such routes, it might trigger a condition where multiple route components may match. Next, we'll declare the route component for the / about route like so. Let's test this in the browser and you can see it works beautifully. Not only are components rendering as desired, the URLs are changing in the address bar as well. This means if someone accesses the / about route directly, the app, a single page application, will correctly render the about component in the content box. We'll thus define all our routes this way. Now, you might be wondering why we use the switch component to encapsulate our route component instances. You see, the route component by itself is all that we need to keep URLs and components in sync. But when multiple route components are present, they will all attempt to render at the same time. They're designed to render, that's by design. The switch here simply ensures that only one of the enclosed route component instances actually gets to render, the one with the best matching pattern as per the URL in the address bar. Alright, this works beautifully. As you saw in this example, we got our router up and running using a simple and declarative API. We used standard component composition here instead of writing a separate configuration. This is known as dynamic routing. While this matches routes to their components, what about route paths that are not matched? To handle 404s or when a specific route cannot be handled, you can add another route component with the path set to an asterisk, as you can see here. The no match component here will be rendered when the switch component is unable to find a defined route handler component. This is optional. We have not implemented this in our project, so go ahead and try this one out as an assignment. Let's continue working with this example and introduce nested routes in the next video.